Hi there and welcome to tutorial 22 on finding the mean and standard deviation of the normal, and this is for the Edexcel S1 A-level course but is applicable to most other exam boards. And as always, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Okay, so this is the second last video of the course, and in the interest of keeping things snappy, we're just going to do 3 quick examples and then wrap it up there. Okay, so let's start with finding the mean. Suppose I'm given a random variable x and I'm told it's normally distributed with a mean mu and a standard deviation of 5 squared. A variance of 5 squared. That means that the standard deviation in this case is 5. And we're also told that the probability that x is greater than 23.43 is 0.05. We're asked to find the mean. As always with pretty much every standard normal question, we want to use a few diagrams to help us work out the problem. So what do I know? I know that the standard deviation is 5, and I'm also told that the probability that x is greater than 23.43, that's 5%. So what I'm going to do is have a look at my graph here, and because this probability is so small and we're talking about a variable being greater than 23.43, that means I'm looking to the right side of the curve, and that this section in here is worth 0.05, remembering that both sides of the normal are equal to 0.5 in total. This value here then must be 23.43, and what we're going to do is calculate a value for z and then see if we can solve an equation to get the mean. So we're going to look at our diagram down here and basically form we're going to transform this graph into the standard normal, which has a mean mu, and the probability will be the same. It will be 0.05, and this value is going to be my z value. Okay, so now that we've formulated the problem, we must remember that the standardized value is equal to the raw value minus the mean over the standard deviation. So this formula here, which we learned in the previous video. So I know that 23.43 minus the mean in this case divided by the standard deviation, which is 5, must be equal to this z value. So I'm going to go to my table and see if I can work out what z is. So if we go to the standard normal table, it's very rare that we see probabilities given to such accuracy. This is 0.05. So on this regular table here, 0.05 I can't find because it's actually below 0.5, and that's where it starts. You can see the probability starts at 0.5 here and goes all the way up to 1. I need something much smaller than that, and I'm also looking to the right. This table here only deals with probabilities to the left of z. We're looking at probabilities to the right, so I'm going to go to my percentage points table. So if I go to my percentage points table, can I find a value for 0.05? And I can. If you look here, I can see a probability of 0.05 gives me a z value of 1.6449. So if the probability is 0.05, the z value must be 1.6449. So I can simply plug that into my equation here. It must be 1.6449. And that's the corresponding standardized value when given a raw value of 23.43. So 1.6449. And now I simply have an equation here, and I'm going to solve for mu. So the first step in the process is I'm going to multiply both sides by 5. So when I do that, let's crack out the calculator. I'm going to do 1.6449 multiplied by 5. That gives me 8.2245. 8.2245, and that's equal to 23.43 minus the mean. Okay, so now what I'm going to do is I'm going to bring the mean over to this side and bring 8.2245 over to the other side. So we get the mean equals 23.43 minus 8.2245. So going back to my calculator, 23.43 minus 8.2245 gives me a value of 15.2055. So let's take it to 3 sig figs. I'm going to say it's 15.2. And that's the question sorted. Okay, let's move on to the second example. We're asked now to find the standard deviation if a random variable x is normally distributed with a mean of minus 32 and a standard deviation of, well, that's what we're looking for. The probability is given that x is less than minus 31.3 is equal to 0.9. And we're going to find the standard deviation, or sigma. So, just like the last question, we're going to use diagrams to help us solve this problem. So what are we told? I'm told that my random variable has a mean of minus 32. So that, as always, goes right in the middle. We're looking for the standard deviation. But I'm also told that the probability that x is less than minus 31.3 equals 0.9. So I'm thinking of probabilities that are smaller. So I'm going to look to the left. Now, because the probability is so big, that means that my value must be over here. My raw value must be over to this side, because I'm told that everything to the left of it gives a probability of 0.9. So that's 0.9. I'm actually going to put in that this must be 0.1 here, because the total probability under the curve is equal to 1. Now my raw value is minus 31.3. So that must go here, minus 31.3. You might be thinking immediately, well, hang on a minute, 31.3, it looks like it's smaller than 32. No, it's not. It's over to the right. Think of your number line. As we go to the right, we're getting closer to 0, so this is correctly positioned. Now let's draw the other diagram. So we're going to use this diagram and map it onto a standard normal, which has a mean of 0. My z value is going to be here. This is still 0.9, and this is still 0.1. Okay, so just like before, we can use the fact that we know z is equal to x minus mu over sigma, where x is my raw value and mu and sigma are the mean and standard deviation respectively. So I know that my raw value, which is minus 31.3, subtract the mean, so I'm going to take away the mean, which is minus 32, and we should be quite comfortable knowing that a negative with a negative beside it, negative take away negative, or minus minus beside each other, actually becomes positive. So that's plus 32. Divided by the standard deviation will equal the z value. So I'm going to try and calculate what my z value is now with a probability of 0.9 to the left or 0.1 to the right. So let's go back to our normal distribution table. So can I find 0.9 as a probability to the right, or to the left should I say? Well, looking at the probabilities here, we've got 0.8997 and 0.9015. Both of them are quite close to 0.9 but not exact. So I'm actually going to see if I can find a probability greater than 0.1 and the corresponding z value in the percentage points table. So if we look over here to the right of z with a probability of 0.1, that actually does have a particular value, 1.2816. So Z must be 1.2816. And that was for the percentage points table using this probability here. So Z equals 1.2816, and that's equal to, well, minus 31.3 plus 32 equals 0.7. So it's 0.7 divided by the standard deviation equals 1.2816, which implies that 1.2816 sigma equals 0.7. And then we're going to divide both sides by the coefficient of sigma. So dividing both sides by 1.2816. 1.2816. And let's bring out the calculator again to get this value. Don't want to be trying any more calculations in my head, particularly this one. 0.7 divided by 1.2816. Right, 0.5461922.597. Let's take it to 3 sig fig, which gives us 0.546. So the answer is 0.546. And there we have it, folks. We've got the standard deviation. Okay, so this problem we're going to look to find the mean and the standard deviation. So x is normally distributed with mean mu and standard deviation sigma, or variance sigma squared, with a probability that x is greater than 1132 equal to 0.2 and x less than 1056 equal to 0.6. Find the mean and the standard deviation. So we're going to need our formula again, and we're also going to need to solve some simultaneous equations. Okay, let's crack on with a couple of diagrams just like before. Right, so the random variable has a mean mu, which is going to go there, and I'm also told that the probability that x is greater than 1132 is equal to 0.2. Okay, once again, we've got a small probability, it's less than 0.5, and we're looking at greater than, so we're going to look to the right. And because the probability is so small, it's less than 0.5, we're talking about this region here, and this raw value is 1132. So I'm going to look to use some equations here and form an equation for mu. Right, if I go to my tables, in fact, let's draw the original or the standard normal. So the standard normal has a mean, 0, and some sort of standard deviation. We're going to look for a z value that has a corresponding probability to the right of 0.2. So bringing up the table, 0.2 seems like a very accurate probability, so I'm thinking percentage points. Let's have a look here. 0.2, have I got a value for that for an area to the right of z? Yes, I do. 0.2 here gives me 0.8416. So the z value is 0.8416. Okay, so let's pop that into our equation here. I know that the raw value, in this case 1132, minus the mean over the standard deviation, sigma, equals 0.8416. And I'm going to use that as equation 1. Before I do that, I'm going to cross multiply by sigma. So I get 1132 minus mu equals 0.8416 times sigma. So that's equation 1. Now I'm going to make a little bit of space here by wiping these out because I'm going to have to draw another couple of diagrams. So I'm also told that x less than 1056 is 0.6. Okay, we got a large probability. It's greater than 0.5 and we're looking to the left. If it's greater than 0.5 and we're looking to the left, it must be over here somewhere, okay? So That's mu. Somewhere over here is 1056. And the probability of this region is 0.6, which also means that the probability of this region is 0.4. Okay, so we're going to transfer that to the standard normal. So that value there, or my z value, is going to have probability to the left of 0.6 and probability to the right of 0.4. Let's go to our table. Is there anything to the right that's 0.4? There is indeed 0.2533. So that's my z value. So the z value is 0.2533. Let's just double check that. Yep, 0.2533. Okay, so we're going to form a second equation. This is equation 1. Now we're going to form equation 2. So I know, using the formula again, that the particular value, 1056 minus the mean, mu, divided by the standard deviation, sigma, equals the z value in this case, 0.2533. Okay, we're going to cross multiply now by sigma. We get 1056 minus mu divided by the standard deviation equals 0. I beg your pardon, we're not dividing by the standard deviation anymore. It is late in the evening. Okay, 0.2533 sigma. Excellent. Now we have a second equation. So we've got equation 1 here and equation 2 here. Okay, so what I'm going to do is I'm actually going to do equation 1 and I'm going to subtract equation 2. So we get 1132 minus mu equals 0.8416 sigma. And that's equation 1. Equation 2 is 1056 minus mu equals 0.2533 sigma. We're tight for space over here. Okay, so we're doing equation 1 minus equation 2. So let's start with the top. 1132 minus 1056 is 76. So 76. Minus mu minus mu. So let me just write down what I'm doing here. We've got negative mu, and I'm subtracting negative mu. Two minuses magically become a plus and they cancel out. That's going to equal, so I need to do 0.8416 minus 0.2533 gives me 0.5883. 0.5883. Technology let me down there. Okay, so if I want to work out what 1 sigma is, or just sigma on its own, I'm going to divide both sides by 0.5833. So 76 divided by 0.5833 gives me 130.29. So let's write that down. 130.29. Let's take it to 3 sig fig, so 130. Okay, now that we have that, let's move on to finding mu. So because I know sigma, I can substitute into one of the equations and get mu. Both equations are pretty difficult to use, so let's just choose equation 1 and swap colors. So using equation 1, we get 1132 minus mu equals 0.8416 times sigma, which in this case is 130. Alright, 0.8416 multiplied by 130 is 109.408. So 109.408. Then we're going to subtract 1132 from both sides. Well, in fact, I'm going to bring mu over to the right. That will make it positive, and take this value here over to the left. That will make it negative. So we get that mu equals 1132 minus 109.408 gives me 1022.592. Let's go to 4 sig fig here this time. So 1023. 1023. And now we found both the mean and the standard deviation for our normal distribution. Okay, so just before we finish up, I just want to give you a quick note with regard to the normal distribution and the fact that it's symmetric, because sometimes examiners try to trip students up by telling you information such as the lower quartile and the upper quartile, and then you're asked to work out the mean. Now, because it's symmetric and you have the lower quartile and the upper quartile, that forms the middle 50% or the interquartile range of the data set. So if I have the lower quartile and I have the upper quartile, I can actually get the mean very easily. Let's suppose that the lower quartile was -3 and the upper quartile was, well, let's do +3 in this case. To get the mean, all I'm going to do is work out the interquartile range, which in this case is 6. So the distance from here to here is 6, which means halfway along the way, or to find the middle value, that's going to be 3 steps ahead. It's half of this. 6 over 2 is 3, so half of it is 3. So if I want to get the mean, I just move 3 steps forward, which means the mean in this case is 0. And that's all down to the fact that it's symmetric. Another helpful fact, because it's symmetric, is when a data set is symmetric, that means that the mean equals the median equals the mode. So if in a question you've calculated the median already and then you have to use a normal distribution, you also know what the mean is because it's symmetric. Okay, that's it for this video. Hopefully you found it useful. I'll be back again soon enough with the final video of the course. Before then, make sure you try exercise 9D, and well, that's it for now. So talk to you again sometime. Take it easy.